Alright, in this question it wants us to sketch a graph that satisfies the given conditions. So if f of 0 equals 0, f prime of negative 2 equals f prime of 1 equals f prime of 9, all equals 0. The limit of f of x as x approaches infinity is equal to 0. The limit as x approaches 6 of f of x is equal to negative infinity. F prime of x is less than 0 on negative infinity to negative 2, 1 to 6, and 9 to infinity. F prime of x is greater than 0 on negative 2 to 1 and 6 to 9. F double prime of x is greater than 0 on negative infinity to 0 and 12 to infinity. F double prime of x is less than 0 on 0 to 6 and 6 to 12. So to start graphing this, one important thing that we want to look at is the limit as x approaches 6 of f of x is negative infinity. So we know that as x approaches 6 from both sides, it is going to approach infinity. So that means that there's going to be a vertical asymptote there at 6. We're going to put in our vertical asymptote. Alright, then we have it up from both sides going from infinity up like that. Now it also says that the limit of f of x as x approaches infinity is equal to 0. So we know that somewhere over here it is going to be approaching 0. We don't know yet if it's from positive y or negative y. So we'll go to f of 0 equals 0. So pretty much that tells us if we input 0, we're going to get 0. So there's going to be a point right at 0, 0. Alright, next we have f prime of negative 2 equals f prime of 1 equals f prime of 9 equals 0. What that is telling us is that there's either going to be, these are our critical points, so they're either going to be a local max or a local min. So if we look on here, f prime of x is less than 0 on negative infinity to 2, 1 to 6, and 9 to infinity. So that means that our graph is going to be decreasing on those intervals. So if we look, start at negative 2. At negative 2 here we can see it goes from negative to positive. When it goes from negative to positive, that means it's going to be a local minimum. So we'll put it about right here. So we know that it's going to be a local minimum. So we'll start the graph from right there. Now, here, it also changes from negative to positive at 6. You see how they have 6 in common. So that also means that it's going to be a local minimum, which it is, or well, it's also an absolute minimum. Now, the next thing that we want to look at is that it is concave up because it is greater than 0 at negative infinity to 0. So if we look right here, we made it concave up like that. So we know at 0 it's concave down. So we know at 0 it's going to switch from concave up to concave down, which is a point of inflection. So we're going to start it right there. Our next critical point is at 1. So we know that at 1 it changes from positive and then it goes to negative. So we know that's going to be a local maximum. we'll mark right here at 1, and have it go down, and then it's going to connect with our point that's at our asymptote. Just get rid of that. Now the next critical point is a 9, and as you can see on the graph, it goes from positive to negative. So we do that, we know at 9 is going to be a local maximum. Went too far. We want that to be the top of the curve. Now, as we can see right here, f double prime is less than 0 on 0 to 6 and 6 to 12. And then right here we can see that it is greater than 0 on negative infinity to 0 and then 12 to infinity. So we know that when f double prime changes from negative to positive, it is going to change concavity. So right here, going to 12, we're concave down. So we know at 12, it's a point of inflection, and it's going to change from concave down to concave up. Now if we go back to our limit as x approaches infinity at f of x equals 0, and we know that it is going to be continuously concave up. We know that it is just going to continue forever to approach 0, but it will never get to it. And that is a graph that satisfies all of these conditions. We have concave up from negative infinity to 0. Then it changes to concave down from 0 to 6, where we have our asymptote. And it stays concave down from 6 all the way till 12, when it changes concavity, and then it goes all the way to 0 and approaches it, but it never reaches it.